On the morning of January 28, 1986, the Space Shuttle Challenger exploded shortly after taking off from the Kennedy Space Center in Florida. It was the first fatal accident involving the Space Shuttle, killing all 7 crew members aboard. First launched in 1981, the shuttle was a partially reusable low-Earth orbital spacecraft. A total of 5 shuttles were built, and flew a total of 135 missions until the program was retired in 2011. Missions included the launch of numerous satellites, interplanetary probes, and the Hubble Space Telescope. The shuttle crew would conduct science experiments in orbit, participated in the joint Shuttle-Mir program with Russia, and participated in construction and servicing of the International Space Station. During the 1950s, the United States Air Force proposed using a reusable piloted glider to perform operations such as reconnaissance, satellite attack, and air-to-ground weapons deployment. In 1957, the Air Force conducted a study on the feasibility of reusable rocket boosters. This became the basis for the aerospace plane, a fully reusable spacecraft that was never developed beyond its initial design phase in the early 1960s. In December 1968, NASA created the Space Shuttle Task Group to determine the optimal design for a reusable spacecraft. By 1972, President Richard Nixon had approved the Space Shuttle. The shuttle included the orbiter vehicle, a pair of recoverable solid rocket boosters, and the expendable external tank containing liquid hydrogen and oxygen. Each field join in the rocket boosters was sealed with 2 rubber O-rings around the circumference of the booster. The main purpose of these O-rings was to contain the hot, high-pressure gases produced by the boosters. On April 12, 1981, the shuttle Columbia took off on the first ever shuttle mission, spending a total of 2 days in space after orbiting the Earth 36 times. By 1986, the shuttle program had undertaken 24 missions, 9 by the Challenger. The crew was announced on January 27, 1985. A total of 7 astronauts, including the first civilian, schoolteacher Krista McAuliffe, who flew as part of the Teacher in Space project. The air temperature on January 28 was predicted to be a record low for a space shuttle launch. The temperature was forecast to drop to 18 degrees Fahrenheit or -8 degrees Celsius overnight, before rising to 26 degrees Fahrenheit, -3 Celsius, at the scheduled launch time of just after 9:30 a.m. It was so cold that ice had formed on the launch tower overnight. The mission was delayed in order to allow this ice to melt, and at 11:38 a.m., 2 hours later than scheduled, Challenger was cleared to launch, with the air temperature at 36 degrees Fahrenheit, or 2 degrees Celsius. Shortly after takeoff, dark grey smoke could be seen escaping from the right side solid rocket booster. The cold temperature had prevented the O-rings in the rocket booster from creating a seal. Just 68 seconds into the flight, a plume could be seen coming from this location. A leak had begun in the liquid hydrogen tank of the external tank, causing the plume to increase in size. The flame then burned from the rocket booster into the fuel tank. 72 seconds into the flight, the right solid rocket booster detached partially from the external fuel tank. 1 second later, an explosion occurred in the liquid hydrogen tank, pushing it into the nearby liquid oxygen tank. The right solid rocket booster collided with the tank, causing a massive fireball that engulfed the space shuttle. The orbiter, now at an altitude of 46,000 feet, 14 kilometers, broke into several large pieces. The 2 solid rocket boosters separated and continued in uncontrolled flight until Mission Control initiated their self-destruct 110 seconds after the launch. The crew cabin containing the 7 astronauts separated in one piece from the shuttle. Approximately 30 seconds after the explosion, it began a free fall towards the ocean. On July 28, 1986, NASA released a report on the deaths of the crew, and it found that the findings are inconclusive. The impact of the crew compartment with the ocean surface was so violent that evidence of damage occurring in the seconds which followed the disintegration was masked. Our final conclusions are: the cause of death of the Challenger astronauts cannot be positively determined. The forces to which the crew were exposed during orbiter breakup were probably not sufficient to cause death or serious injury, and the crew possibly, but not certainly, lost consciousness in the seconds following the orbiter breakup due to in-flight loss of crew module pressure. The effectiveness of the solid rocket booster's O-rings came into question. A January 1985 flight was the coldest space shuttle launch to date, at a temperature of 62 degrees Fahrenheit, 17 degrees Celsius. Analysis of the flight identified erosion in the primary O-rings in both rocket boosters. Engineers determined that the cold temperature had caused a loss of flexibility in these O-rings and decreased their ability to seal the joints. In fact, erosion of the O-rings occurred in all but one shuttle mission throughout 1985. A presidential commission was formed on February 6, 1986, to investigate and find the cause of the disaster. It determined that the accident was due to hot gas blowing past the O-rings in the field joint of the right solid rocket booster, and found no other potential cause for the disaster. It attributed the accident to the faulty design of the field joint that made it susceptible to damage in cold weather. The Commission emphasized that both NASA and its contractor had overlooked evidence of the potential safety issues. Recommendations were made to improve the design to prevent the passage of hot gas past these O-rings. The Space Shuttle fleet was grounded for 2 years while the program underwent investigation, redesign, and restructuring. Several memorials have been established in honor of the disaster. Piers Park in Palo Alto, California, features the Challenger Memorial Grove, including redwood trees grown from seeds carried aboard Challenger in 1985.